Hello to all of you. I'm going to take full advantage of the fact that I have a voice for the most part right now. So, to get this video in while I still have one. For today, we are going to continue on from what we started yesterday. And yesterday, if you remember, was an introduction at looking at orangutan populations. I know it seems kind of, why are we looking at this, Ms. King? It's going to start to make sense. I remember I told you that this unit, after we did our review, we're looking at those relationships that exist in ecosystems, that exist in, if we wanted to narrow it down to the interactions in an identified food web. Okay, because we've already looked at relationships between the biotic factors and the abiotic factors. And so we're shifting that focus to focus more on the biotic factor relationships with other biotic factors. But we have to look at a population first, where they exist, how they exist, what makes that a healthy balance. So first thing that I want you to do, you're going to continue on with your notes that you started yesterday. And I want you to add the word population. So this is something we have discussed a few times, but I want to make sure we have it in writing. Okay, in writing, in your science notebook. Go ahead, take a moment to get that out. Make sure you pause this though. I don't want you missing anything. Get this definition in there, and then I want you to write what you think would be a good way that we could represent the idea of populations. Okay, these are just your thoughts. All right, and we're going to keep adding on to that is in your science notebook. There are some things that I want to go back and talk about from the story map. Okay, if you need that link, make sure you go back to yesterday's lessons, access that link if you want to look at it again. And if you did not do yesterday's lesson for whatever reason, if you were absent or you were just making a choice not to, in order to make this worthwhile for you today, you must go back and do yesterday's. Okay, so of the 4 places, which one had the largest population and which one had the smallest? So if we were to go back to those 4 locations, here's the first one. Okay, the most current population data point was from 2008 at 6,600. Here's the second one, 2,500. Here's the third one of 600. And here's the fourth one, 1,401. Which one has the largest population and which one has the least? And then what is the approximate population of orangutans in each area? Do you know how to do that? If you're stuck on that one, you're in luck, because I'm going to help you with that one today. Moving on to the next one. Why do you think the populations of orangutans in an area didn't always remain the same? So if we go back to those, we have a really high population of over 12,000 initially. 5 years later, dropping by 8,000. It's pretty significant. Here we have 2,895, 6 years later. And for the 7 years following that, 2,500. This one here at 600. And then this one from 1,285 to 401. Why do you think that those fluctuations existed? And why do you think that some areas have more orangutans than others? Because we just looked at that. They may be close in numbers, they may be similar, but they're not identical. Why do we have this variation in population of these orangutans? What do you think? So these are your points to ponder. Jot down your ideas in your notes. You do not need to write out all of these questions. Make sure you pause the video though, because I'm going to keep on moving. 15 minutes isn't long for me to get everything in that I need to talk about today. So I did ask, if we go back for 1 second here, I did ask the population in the area, in each area. Okay, so we do have those numbers that were given to us, but let's make it a little clearer, because look, I can tell you there are 1,600 orangutans in a location, but does it have a lot of meaning? We still have a lot of unanswered questions there. Okay, so we're going to narrow it down a little bit further, and we're going to figure out how many orangutans can fit in 1 square kilometer in each of these national parks. Okay, so that does mean that today we're going to take a trip down ratio lane, or equivalent fractions. Any of the above would be fine to consider. But we're going to take a little bit of time to practice this. Hey, look, we have a way of showing how to narrowing this down, because yes, population can fluctuate, fine. But what are we looking at in a square kilometer? How many orangutans are there? How many are thriving in that specific place? Okay. So if you know how to do this, great. If you're not so sure, well, make sure you're following along, because I'm going to walk you through this a couple times, and then I'm going to have you do it on your own. Okay, so if you need to rewatch my examples, hey, that's the benefit of this being recorded. You get to do that. If you're like, yeah, Miss Single King, I know how to cross multiply and I can solve for that question mark, awesome, love it, you can fast forward through this part because it doesn't apply to you. Or you can watch an example, get the refresher, and then move on. So let's talk about this one here. This is from that first system that we were looking at, that first national park, from 1993. In 1993, there were 12,040 orangutans in the 700 square kilometers. I want to know how many orangutans were living in 1 square kilometer. I got to solve for that question mark, right? So here's what we can do. We can do this awesome little butterfly method and do some cross multiplying, right? So we're going to end up with that 12,040 divided by 7,000, okay? I wonder what that is. And you have a great calculator feature that is built in, right? So let's head on out to that calculator. Let's do some division. 12,040 divided by 7,000 equals 1.72 orangutans per square kilometer. Okay. Yes, I'm sorry I didn't write out the word orangutan, but I'm using my stylus on here. So challenges, we all have them. 12,040 divided by 7,000 square kilometers. Okay, I'm showing you this butterfly method. This is what your math teachers are going to teach you to do if they haven't already done so, and I'm pretty certain they have. Let's do another one. And I'm just going to show you on the screen here because, hey, you're probably going to need to make this data table. I say probably, like, it's optional. Like, you should. All right, so we're getting about 1.72 orangutans per square kilometer. That was in 1993. What about 1998? Let's set it up again, okay? What was our population? We had 4,710, and our area was still 7,000 kilometers. That did not change because that's over here, right? And then I'm just going down the population size here. So we did this first one, and now we're on the second one. So if I have my population over top of my area, how many orangutans are going to, how many orangutans are living per square kilometer here? Back to that calculator. Okay, we're doing that cross multiplying again. And we end up with 4,710 divided by 7,000. We are... Hold on. I did a subtraction. That didn't come out right. Let's try the correct operation here. Divided by, there we go, 7,000. So we're getting a less than 1 per square kilometer. So 0.67, less than 1. Interesting. I wonder why that happened. What? But didn't I have like a 1 3/4 of an orangutan before? Let's do one more together. I'm going to go down to, let's see. I'll just go down to the next national park. We are going to look at the year 1995. And we had 2,800 orangutans in a 1,080 square kilometer national park. Let's divide that one out too, right? 2,800 divided by the area. Holy cow. 2.59. I got 2.5 orangutans, over 2.5 orangutans per square kilometer. Okay. You're going to keep doing this until you have figured out how many orangutans live in each square kilometer. Okay, for each year that data is collected, it's important to look at these changes over time. Okay, make sure you pause the video, come back when you are done. Remember, it's just a division problem and you can use a calculator. Population goes in the numerator spot and the area goes in the denominator. All right, let me help you out just a second. Here's a spot check. Check your answers in your data table if they are aligning. Pretty close to what I've got. You did it well. Good job. If they are not, please go back and check your math. Okay? Remember, it is the population over the area. Okay? I know I showed you all that cross multiplying, but some of you already figured out it's the same thing as just doing that one division problem. All right. And now that you have all of those spot checks done, let's talk about analyzing that data. Wow. This is something that's kind of a challenge some days. But we're going to break it down into an identify and interpret strategy. So you're going to first make observations. There are 3 steps there. And then second, you are going to interpret what those observations mean. Do this in your notebook. What is it that you see? And tell me what it is that it means. Pause this so that you have time to work. So do you think that 20 or more orangutans could live in the same 1 square kilometer space? Why? Were there any patterns that showed up in that data that could support your answer? All right, and it all comes back around full circle here to our guiding question, right? How many orangutans can we get there? How many orangutans live there? And can we count those populations? All right, so why is it that we can only get 1 to 3 orangutans, 1 to 3 per square kilometer? Why? What do you think? You may brainstorm this with someone near you. You can put down your list of ideas in your notebook. And this is what will take us into tomorrow's lesson.